This is Module 7, Section 2.4, and the very first part of Section 2.6. In this section, we will be looking at problem solving, and there are four basic types of problems that we're going to look at. They are general number problems, consecutive integer problems, board length problems, and percentage problems. In Module 6, we practice translating words into symbols and then into algebraic expressions and equations. We are now going to apply that skill to solve application problems. There is a basic strategy for problem solving. Mostly, though, for application problems, experience is probably your best tool to getting comfortable with story problems. First thing you want to do is read and understand the problem. Mentally list what items are known and what items are unknown, or what are you trying to find. You want to assign a variable to one of the unknown items. Usually that means letting x be equal to the item that is asked for in the problem. X is equal to the length, x is equal to the width, x is equal to the number, whatever you're trying to find. Then you're going to translate the other information in the problem into expressions using this same variable, looking for key words. Construct a drawing if applicable. A lot of times a picture is worth 1,000 words, and simply by drawing a picture, sometimes it's fairly easy to see what the problem is asking. Then put all the information together to write an equation with an equal sign that describes the problem, because you have to have an equation to solve, and then solve your resulting equation. After you get an answer, this is important, you need to interpret or check your work to see if your answer makes sense. For example, if you're doing a problem and the problem is asking you to determine how tall a building is, and you find out that your building is 5,000 miles high, logically that doesn't make sense. So that's a logical way to check your answer to see if perhaps you made a math error. For this section, we will be concerned about four specific types of problems. We're looking at general number problems, consecutive integer problems, board length problems, and percentage problems. So we're going to start with that first type, general number problems. And I think the best way to demonstrate these types of problems is simply to do it examples so you can see the type of things they'll ask. For example, 5 times the sum of a number and -1 is the same as 6 times the number. Find the number. All right, we're going to start with assigning our variable. Usually the variable is the thing that they're actually asking you to find. In this case, they're asking you to find the number that they're talking about. So that's what we're going to let our variable be equal to. I'm going to choose to let x be my variable. You can choose whatever letter you would like. A lot of people like to use n since it's a number, but we're going to let x be the number. After that, it's much like the previous module. You're looking for keywords as you read the problem. We have the keyword times. We have the keyword sum. Is the same as is a keyword for equals. And then 6 times, there should be an S on the end of that, also is a keyword. So reading left to right. 5 times means multiplication. So you've got 5 times. Now, 5 times what? Well, it says you're going to take 5 times a sum. So you're going to have to do the addition problem first before you multiply it by 5. That means grouping symbols, because it's 5 times the entire answer that you get with that sum. So now ask yourself, what are you adding? Well, you want to know the sum of a number, which is x, because we said so, and -1. So 5 times the sum, or the group, of x plus negative 1 is the same as, that means equals, 6 times, that's 6 times what? 6 times the number, which again is x. All right, so you have your equation. No picture is necessary here. So now we're simply going to do the math, simplify as before. So we're going to distribute the 5. This is a distributive property step. 5 times x is 5 times x, plus 5 times negative 1 is 5 times negative 1. And that's equal to 6 times x is simply 6x. Clean it up. 5x plus negative 5 is equal to 6x. Okay, we're trying to solve for x, so we're going to get our x's on the same side. Therefore, I'm going to choose to get my x's on the right-hand side. So I have a positive 5x here, so I'm going to subtract 5x from both sides. They're going to cancel out on the left-hand side. Now we have, if we bring that up, negative 5 left by itself on the left-hand side. 6x minus 5x is 1x, which is the same as simply saying x. Our variable's isolated. We have our solution. X is equal to negative 5. Ask yourself now, have I answered the question? The question was to find the number. X was my number. I solved for x. I should be good to go. Another example. One number is 3 more than twice another. Their sum is 18. Find the numbers. Okay? Now in this case, you're looking for more than one number, but you can't use 2 variables because you don't know how to solve those equations. You can't have an x and a y in an equation and solve it yet. So you're still going to have to let x, some form of x, represent both those numbers that they're asking you to find. So start by assigning x to be one of the numbers that you're trying to find. Now the other number is going to have to be related to that number. And notice that it says here that one number is 3 more than twice another. Okay? So if we take this number here as being our x, okay? If we take twice another, that would be 2 times x. And then the number that we're trying to find, this is our other number that we're trying to find. It is, okay, this is our other number, 3 more than. More than is a keyword for addition. And then 3, of course, is 3. So 3 more than twice another would be 2x plus 3. Twice another is 2x, and then 3 more than that would be plus 3. So now you have your 2 numbers. X is one of the numbers. 2x plus 3 is your second number. And then the next sentence, their sum is 18, is how you're going to put those 2 numbers together to get an equation. It says that your 2 numbers, okay, so one number plus, that's what sum means, plus your other number is, means equals, 18. One number we let be x. The other number we let be 2x plus 3. Those 2 added together should give us 18. Now it's just a matter of combining like terms. 1x plus 2x is 3x, plus 3 equals 18. Subtract 3 from both sides. We're isolating our x. 3x is equal to 15. Divide both sides by 3. Again, from the previous module, we are isolating our x. And x is equal to 15 divided by 3, which is 5. Now it seems like we're done, but notice that they ask us to find the numbers. They want us to assign a value to both. So if we come back to our original setup over here on our left, x is one of the numbers. Okay, so one of our numbers is 5, which is what we solved for. The other number is 2 times that value, which is 5, plus 3. So we need to do that math. 2 times 5 is 10, and if we add 3 to that, we get a second number of 13. So our two numbers are 5 and 13 for our final answer. Next example. 5 times the difference of twice a number and 6 is negative 20. Find the number. Again, we're simply looking for a single number here, so I'll let x represent that single number we're trying to find. Now, reading left to right, we're going to put our equation together, look for key terms. 5 times, that's multiplication. 5 times. 5 times what? 5 times the difference. Now, difference means subtraction, and so you're multiplying that 5 to the answer that you get after you subtract. You're going to have to use parentheses here. Okay, what are we subtracting? We're subtracting, or we're finding the difference of twice a number. Twice means multiplication. Twice a number is 2 times that number, 2x, and 6. You're finding the difference of 2x and 6. That translates to 2x minus 6 because difference means subtraction. Then is a key word for equals, negative 20. There's your equation. Again, with number problems, rarely do you need to try to draw any kind of picture. Now, notice that if I drop that multiplication dot, this first step on the left-hand side is distributive property. So we're going to take that 5 and multiply it to each of those terms. We've got 5 times 2x minus 5 times 6 equals 20. 5 times 2 times x is 10x, minus 5 times 6 is 30, equals 20. Now we've got, if we add 30 to both sides, we're trying to solve for x, so I'm getting my x on the same side by itself. If we bring this up here, we've now got 10x is equal to 2 plus 30 is 32. And if we divide both sides by 10, we've got x equals 32 tenths, which can be reduced if we take out a 2 here. 32 divided by 2 would be 16 fifths. And that is in simplest form. All right. Next problem. The sum of 2/3 and 4 times a number is equal to 5/6 subtracted from 5 times a number. Find the number. Again, we're simply trying to find a single number, so we're going to let x represent that number. We have to have something to solve for. Reading left to right, we're looking for the sum. That means addition. The sum of what? Well, we're adding 2/3 and 4 times a number. Okay, so we're adding 2/3 and 4 times our number. So 2/3 plus 4x is equal to, that means equals, 5/6 subtracted from, oh, watch out there, I should have read the rest of the problem. They're telling you that the 5/6 is subtracted from 5 times a number. Order is important in subtraction. Okay, 5/6 subtracted from means we're subtracting the 5/6 from something else. What are we subtracting it from? We're subtracting it from 5 times our number, or 5 times x. Okay, so now we have an equation with fractions in it. So from Module 6, we want to clear those fractions. Remember in Module 6, the technique we used is we looked at the denominators in the problem. In this case, there's a 3 and there's a 6. And we were interested in the least common multiple of 3 and 6, or the least common denominator if you were building those fractions up. Least common denominator of 3 and 6 would be 6. But what we're doing with that 6 is we're going to multiply each and every term by 6 in the problem. So we would get 2/3 times 6 plus 4x times 6 equals 5x times 6 minus 5/6 times 6. Remember, those 6's are up in the numerator. And the reason that's important is now if you look at the original fractions in the problem, the fraction denominators should cancel out. Okay? Here on this first fraction, we've got a common factor of 3. 3 divided by 3 is 1. 6 divided by 3 leaves you with 2. Over here on this last fraction, we can take out a common factor of 6. 6 divided by 6 leaves us with 1. Here, 6 divided by 6 leaves us with 1 as well. So now, if all of your denominators have canceled out and you're left with a bunch of 1s, you can ignore them because anything divided by 1 is itself. So do the math up top. 2 times 2 is 4, plus 4 times x times 6 is 24x. That's equal to 5 times x times 6, which is 30x, minus 5 times 1 is minus 5. All right, so now we want x's on one side and our constants on the other. So I'm going to choose to subtract 30x from both sides. Get all our x's to the left-hand side. That will allow me to combine like terms on the left-hand side here. We've got 4 plus 24 minus 30 is a negative 6x. And that's equal to, on our right-hand side, negative 5. Now, subtract 4 from both sides. And we've got negative 6x is equal to negative 9. Divide both sides by negative 6. And x is equal to negative divided by negative is positive 9/6. That can be reduced, so you must reduce it. There's a common factor there of 3, so we're going to divide 3 out, top and bottom, for a final answer of positive 3/2. So our number is 3/2. All right, so now we're going to move on to board length problems. Board length problems are very similar to number problems. They're just applicable to a more real-life situation than just the generic number problems. So in this case, a picture is worth 1,000 words. So reading the problem, a 28-inch board is to be cut into 2 pieces so that the longer piece is 3 times the shorter. Find the length of each piece. All right, so there's 2 things you're trying to find, the length of the short piece and the length of the long piece. But you have to let your x represent just one of those 2 to start with, because it can't represent both of them. So notice that when you read the problem, they talk about the longer piece in terms of the shorter piece. So if you know what the shorter piece is, then you can set up a relationship to represent the longer piece as well. So we're going to let x be equal to the shorter piece, because the problem says that the longer piece is 3 times the shorter. Now that's multiplication. Okay, 3 times the shorter piece, we just said the shorter piece was x. So 3 times the shorter piece would be 3x. Okay, draw yourself a picture. We've got a board, and we're cutting that board into 2 pieces. Obviously, the shorter piece and the longer piece. We figured out that the shorter piece, because we said so, was going to be x, and the longer piece is 3x. Notice the problem also tells you how long the board is. The entire board, from end to end, before you cut it, is 28 inches. So, can you look at that picture and figure out a way to put all that information together into an equation? Do you agree with me that the short piece plus the long piece has got to be equal to the length of the entire board, which is 28? Okay? We know the short piece is x, we know the long piece is 3x, and when we add those two together, that gives us a total length of 28. Okay, there's your equation. Get x by itself. Isolate x, just like with any equation. X plus 3x, remember x is the same as 1x. 1x plus 3x is 4x, equals 28. Divide both sides by 4, and x is equal to 28 divided by 4, which is 7. Have we answered the question? Well, no, not completely, because we have two pieces to identify. We've just identified the short piece. Okay? 7 is the length of the short piece, and you want to ask yourself in application problems, well, 7 what? The units will remain constant. So if the original board was in inches, then the length of the short piece also is in inches. So the short piece is 7 inches. The long piece is 3 times that 7, which in this case is 21 inches. And a quick check to see if that makes sense. If you take 7 inches and add to that 21 inches, do you get the total length of the board of 28? And the answer is yes. So the length of each piece, short piece is 7 inches, and the long piece is 21 inches. Next problem. A 46 piece of rope is cut into 3 pieces so that the second piece is 3 times as long as the first piece, and the third piece is 2 feet more than 7 times the length of the first piece. Find the lengths of the pieces. Okay, now this problem has 3 pieces. Okay? You've got your first piece, and your second piece, and your third piece. One of those 3 has to be x. So the question then becomes, well, which one should you let be x? And does it matter? And the answer is, it doesn't matter. You could work it anyway, but it's much easier if you let x represent the piece that everything else is referring to. So if we read the problem again, notice it says that the second piece is 3 times as long as the first piece. So the second piece relates to the first piece. And the third piece is 2 feet more than 7 times the length of the first piece. So both the second and the third piece are related to the first piece. So we're going to let x be the first piece. So if x is the first piece, let's look at the second piece. They tell you that the second piece is 3 times as long as the first piece. Okay? 3 times obviously is multiplication by 3. So 3 times the first piece would be 3x. The third piece is 2 feet more than, that means plus 2. Okay? 2 feet more than what? 2 feet more than 7 times the first piece. So that would be 7 times x. 2 feet more than 7 times the first. So if you want to draw a picture, okay, you've got your rope now. You've got 3 pieces. Okay, your first piece is going to be x. Your second piece is 3x. Your third piece is 7x plus 2. Notice they tell you that the original length of the entire rope from end to end is, 46 feet. 46 feet. So you can see easily with this picture that if you add all 3 of those pieces together, that will be equal to 46. So let's do that. We've got x plus our second piece is 3x plus our third piece is 7x plus 2 is equal to the entire length of our rope, which is 46 feet. Okay, working on individual sides, remember you can only combine like terms if they're on the same side. So x, and remember that's an understood 1x. 1x plus 3x is 4x. 4x plus 7x is 11x plus 2 equals 46. Trying to solve for x, so subtract 2 to get the x term by itself. You've got 11x equals 46 minus 2 is 44. Divide both sides by 11, and x is equal to 44 divided by 11 is 4 feet, because the original length was in feet. Don't stop there, though, because you've only answered a third of the question. The first piece is 4 feet, because that's what x was. Your second piece is 3 times that, or 12 feet. And your third piece is 7 times 4 plus 2, or 28 plus 2, which is 30 feet. Now let's do a quick check. If you add together 30 feet and 12 feet and 4 feet, that should be equal to the entire length of the rope, which is 46. So if we add that up, 4 and 2 is 6, 3 plus 1 is 4, 46 feet looks good. And I think that those 3 lengths are correct as long as we set the problem up correctly. All right, consecutive integer problems. In order to do integer problems, I think it's worth a review of what the integer set really is. Integers are basically the counting numbers in both the positive and the negative directions. So we're looking at whole numbers, both positive and negative. So -2, -1, 0, 1, 2, etc. are our integers. The word consecutive means one right after another. So, for example, -2 and -1 are consecutive integers because they come one right after another in the integer set. 2 and 3 are consecutive integers, 9 and 10, etc. Therefore, if you have a consecutive integer problem that you are trying to solve, if x is allowed to represent the smallest integer, notice that in all the pairs above, -2 and -1, 2 and 3, 9 and 10, the difference between the two, or the way you go from the smaller integer to the larger integer, is you add 1 to it. 9 plus 1 is 10. 2 plus 1 is 3. -2 plus 1 is -1. Therefore, in story problems, if x is the smaller integer, then x plus 1 is the larger integer, again, if it's a consecutive integer problem. So we're going to use that to solve problems. Now, there's also a special case of consecutive integer problems, and that is consecutive even or odd integer problems. If they're asking you to find consecutive even or odd integers, where you're talking about even numbers in sequence like 4 and 6, you agree with me that in the integer set, if your first even integer is 4, the next one in line is 6. Then the next one in line would be 8. The next one in line would be 10. Okay? Notice that for even integers, the difference between those numbers is not 1. It's 2 in all those cases. In other words, you'd have to take 4 and add not 1 but 2 to it to get to your next even integer. If the problem deals with consecutive odd integers, odd numbers in sequence, then you might have an answer like 3 and 5, or -9 and -7, or 13 and 15. Again, just like with even numbers, notice that the difference between the two numbers is not 1, but it's 2. So, for example, to go from 3 to 5, you'd have to add 2 to get to that. Or if you were going from 13 to 15, you'd have to add 2. Therefore, if you have a consecutive odd or even integer problem that you are trying to solve, and if you let x be the smallest odd or even integer, then your next odd or even integer will not be x plus 1, but instead will be x plus 2, because there's a difference of 2 between either odd or even integers. So let's look at this example. We've got the sum of two consecutive even integers is 106. Find the two numbers. All right, you've got two numbers to find. You have to let x be one of the two. We're going to use the logic that x is always going to be the smaller of the two even integers. Now you can do it the other way. We're going to do it this way. If you're talking even integers, and you know x is the smaller integer, then if you add 2 to the smaller integer, that will be the larger consecutive even integer, because there's a difference of 2. Once you have that set up, look at what the problem is saying. It's saying the sum of those two numbers, in other words, the smaller even integer plus the larger even integer, because that's what sum means, that's equals 106. So put your representation in for that. Your smaller number we said was x. The larger number we said was x plus 2. Those two added together will give you 106. Solve the equation. You've got like terms over here on the left-hand side. X plus x is the same as 1x plus 1x, so you've got 2x's plus 2 equals 106. Subtract 2 from both sides. We're trying to solve for x. And we've got 2x is equal to 106 minus 2 is 104. Divide both sides by 2 to solve for x. And x is equal to 104 divided by 2, which is 52. Now you're not done though, because you found the smaller integer, but you have to find both integers. So if x is 52, then your larger integer will be 52 plus 2, which of course would be 54. So your two numbers are 52 and 54. Okay, another example. The sum of two consecutive odd integers is 76. Find the numbers. The setup is exactly the same. If you let x be the smaller odd integer, then x plus 2 is the larger odd integer. We're adding them together. It says the sum of those integers. So x plus 2 is negative 76. Solve the equation. Combine like terms on the same side as the equal sign. 1x plus 1x is 2x plus 2 equals negative 76. Trying to solve for x, so let's subtract 2 from both sides. Now we've got, if we bring it up here, 2x on our left-hand side. That's equal to negative 76 minus 2, which is negative 78. Divide both sides by 2. And x is equal to negative 78 divided by 2. And if you don't have a calculator, you can do that off to the side. 2 goes into 7 3 times. 7 minus 6 is 1. Bring down the 8. 2 goes into 18 9 times. So we've got 39. But it's not a positive 39. It is a negative 39, because negative divided by positive is negative. Now you're almost there. That's your smaller number. Okay. The next integer in the series then will be x plus 2, which is negative 39 plus 2, which is negative 37. So your two integers are negative 39 and negative 37. The sum of two consecutive integers is negative 21. Find the numbers. All right, this is a consecutive integer problem, so we're going to let x represent our first consecutive integer. And since it's not an odd or even problem, the next consecutive integer would be 1 greater than that. So we'll let x plus 1 represent our second consecutive integer. All right, once we have that set up, the problem says that the sum, or the addition of those two together, is negative 21. So x plus 1 equals negative 21. Now it's simply a matter of solving the equation. Here we've got understood 1's in front of our x's, so 1x plus 1x is 2x, plus 1 equals negative 21. Trying to solve for x, so let's move that term that has nothing to do with the x. Subtract 1 from both sides. Now we've got, if we bring it up here, 2x is equal to negative 21 minus 1 is negative 22. And if we divide both sides by 2 to isolate the x is equal to negative 11. That's our first integer. Now notice that our second integer is 1 more than that. So x plus 1 will be negative 11 plus 1, which is negative 10. And our two consecutive integers for that problem would be negative 11 and negative 10. The sum of the left and right consecutive page numbers of an open book is 253. Find these page numbers. This again is a consecutive integer problem. So if you let x represent your first page, then x plus 1 will represent the second page in consecutive order. It asks you to add those two together. So x plus 1 is equal to 253, so says the problem. Combine like terms. X plus x is 2x, plus 1 is 253. Subtract 1 from both sides. We've got 2x is equal to 253 minus 1 is 252. We're going to divide both of those by 2, and that gives us a solution of x equals 252 divided by 2. And if we do that off to the side, 252 divided by 2, 2 goes into 2 once. Bring down the 5. 2 goes into 5 twice. 2 times 2 is 4. Subtract and bring down the 2. 2 goes into 12 6 times. So x is equal to 126. And so your next consecutive integer will be 1 more than that, so 127. So your book is laying open at pages 126 and 127. All right, so we're going to move on to percentage problems then. These types of problems are one of the easiest to set up as long as you remember the following, and this is important. All percentages must be converted to decimal form by dividing the percentage by 100 or by moving the decimal 2 places to the left. And if you test that out, if you take any number and you divide it by 100, that'll move your decimal point 2 places to the left. For example, 35%, you can either take that value and divide it by 100 and then get a decimal on your calculator, or if you remember that any number that doesn't appear to have a decimal point, the decimal point is always at the end of the number. If you move that 2 places to the left, that will give you 0.35. Another example, 125%. 125 divided by 100 will move the decimal point 2 to the left. That'll put it between the 1 and the 2. 125% is the same as 1.25. 0.16%. 0.16%, now you want to be careful here. You want to take the entire percentage and put that over 100 if that's the method that you're using. And that's kind of awkward because you're not used to seeing a decimal in a fraction. And so for those of you who like moving the decimal point better, it's not quite as awkward. If you move this decimal point 2 to the left, you'll move it 1 place, and then to move it a second place, you'll have to put in a placeholder 0. So we get 0.0016. 0.0016. Now the key words you want to look for these, because these are also story problems or application, the word of in these problems always means a multiplication step. And as always, the word is symbolic for an equal sign. So let's do a few examples. Looking left to right, this asks, what number, okay, that's what we're trying to solve for, okay, is means equals, 35%. Now you have to convert that to a decimal in order to use it in an equation. So 35% is the same as 35 over 100, or if you move the understood decimal 2 to the left, that ends up being 0.35. So convert it first before you put it into your equation. 35% then is 0.35. The word of means multiplication, and 520, of course, is just a number. So looking at the left-hand side then, we're going to take 0.35 times 520. All right, and if we take 0.35 times 520, in our calculator, we get 182. And there's your answer. Let's look at this example. 44% of what number is 143? All right, change 44% to a decimal. That's the same as 44 divided by 100. Or, if you remember just to move the decimal 2 to the left, that's the same as 0.44. So reading this problem left to right, 44% is 0.44. The word of means multiplication. What number, okay, that's what you're trying to solve for, we'll let that be an x, is equals, and 143. So we've got 0.44 times x equals 143. You could write that without the multiplication symbol there if you like that better. Either way, the opposite of multiplication is division. We're trying to isolate our x, so divide both sides by 0.44. Excuse me. And if we put that in our calculator, 143 divided by 0.44 gives us an answer of 325. All right, so let's do this problem. 3.6 is what percent of 28.8? Now in this case, notice the thing that we're trying to solve for is a percent. So we're going to have to convert it back to a percent because the answer will come out as decimal form because equations always give percents in decimal form. We'll have to convert from the decimal form to the percentage. Okay, so reading left to right, we've got 3.6 is means equals always. What percent, that's what we're trying to solve for. Of means multiplication, and 28.8. Trying to solve for x, so we have to get rid of that 28.8. It's being multiplied, so the opposite of multiplication is division of both sides of 28.8. That isolates your x on the right-hand side, and if we put that in our calculator, we've got 3.6 divided by 28.8, and that gives us 0.125. But that's the decimal form of our percent. So we're going to now have to convert our decimal to a percentage. That's opposite what we have been doing, so let's think in the opposite manner. Before, to convert a percent to a decimal, we were dividing by 100. So if you're going in this direction, you're going to multiply by 100. Or, if you think about it in terms of moving decimals, when we were going from a percent to a decimal, we moved the decimal point 2 to the left. Now, to go from a decimal to a percent, we're going to move our decimal 2 to the right. Okay, move our decimal point 2 places to the right. So over here, if we take our decimal answer, we're going to move that decimal point 2 to the right, which gives us 12.5, and now we can put in that percentage symbol because we converted it to a percentage answer. All right, in our final answer, or problem, the number 126 is 35% of what number? All right, 35% is 35 over 100, or 0.35. So reading left to right, we're taking 126 is, that's equals, 35%, that's 0.35, of is multiplication. What number? That's what we're trying to find. So 0.35x, trying to solve for x, so we're going to divide both sides by 0.35. That cancels it out on the right-hand side, and we get a solution of x equals 126 divided by 0.35 for an answer of 360. So that brings us to the end of Module 7, Sections 2.4 and part of 2.6. You now should complete the homework for Sections 2.4 and 2.6 found in my math lab. And when you have successfully completed the above homework, proceed to the video for Module 7, Section 2.5.